Hi, welcome to this tutorial on series and using sigma notation. Now before we start, what I want to do though is just introduce a sequence. And in this particular example I've taken the rth term in a sequence to be 12 over r. And what that means is that the first term would be given when we set r equal to 1. So when r is 1 we've got 12 divided by 1 and that gives 12. And for the second term we would set r equal to 2 and that would be 12 divided by 2, which is 6. And if we kept this up we could generate further terms like the third term when r equals 3, which comes out at 4, and the fourth term when r is 4 comes out at 3. So we have a sequence. A sequence is a set of terms then obeying a particular rule, and that rule in this particular example was 12 over r. So the sequence was 12, 6, 4 and 3. Now when we add the terms of a sequence up, so if we had this particular sequence and we added the terms 12 plus 6 plus 4 plus 3, then it is called a series. And if we add this particular series up, then what we find is we get 25. The statements like this can be written in shorthand by using the sigma sign. And the sigma sign is this Greek letter. Okay? And used in this particular context, what we would do is write the rth term of the sequence, that be in this case 12 over r here, and we set r going from 1 all the way up to r equaling 4. And how does this work? Well, what we do is basically the same as what we did here. We set r equal to 1 and we get 12 divided by 1, which is 12. But because we've got a sigma sign, sigma means to add the terms. And so we now set r equal to 2, and we have 12 divided by 2, which is 6. Sigma means to add again. We set r equal to 3, and we have 12 divided by 3, which is 4. And then we add the next term when r equals 4. 12 divided by 4 is 3. So this particular notation then is short for showing this series here. And if we add that up, well, we know the result, it was 25. Now what I want to show you now is some more examples that use sigma notation and also to introduce you to some algebraic results. Now in this next example we've got sigma for 2r plus 3 going from not r equals 1, but in this particular example r equaling 3 to r equals 7. So how do we do this? Well, basically the same as we did the earlier one, only we start with r equals 3. And if you substitute r equals 3 into here, you get 2 times 3, which is 6, plus 3 is 9. So the first term in this particular series is 9. That was when r is 3. Now we go up one more to r equals 4, sub it into here, and we have 2 times 4 is 8, plus 3 is 11. And because we're doing the sigma notation, it's plus the second term 11. Now we let r equal 5, sub it into here, and we get 13. Then we let r equal 6 and we get 15, and finally r equaling 7 and we get 17. So we have the terms then in the series, and all we need to do now is just add them up, and that comes to 65. Now in this next example what I want to show you is how we can use sigma notation when we've got a constant multiplied by some function of r. So let's just suppose then we had, say, sigma of 3 times a function of r, like r squared. And also we'll have r going from 1, and what we'll do here is not write r equals 4, but just put 4 at the top. You quite often see something like this. You don't have to put r equals 1 to r equals 4. Just leave it like that. Now what does this mean? Well, what we've got is that when we substitute r equals 1 in here, we've got 3 times 1 squared. And then because we've got the sigma notation, we're adding the value when we put r equals 2 in, so that'd be 3 times 2 squared. And if we keep this up, we've got 3 times 3 squared when we put r equals 3 in, and when we finally put r equals 4 in, we've got 3 times 4 squared. Now you'll notice that 3 is a common factor. So really what I've got here is 3 times all of 1 squared plus 2 squared plus 3 squared plus 4 squared. And what this is the same as is 3 times sigma of r squared, where r goes from 1 to 4. So you can see that all that has happened is that the 3, being a constant, can come out the front of the sigma sign. And if you work this out, you'll find that you get 90. So what I'm trying to demonstrate here is a particular rule that you can often employ when you're working with sigma notation. And that is that if you have sigma of a constant times some function of r, in this particular example the function of r was r squared and the constant a was the 3, and we had r going from 1 to some particular value, let's just call it n, then this was exactly the same as bringing out the constant in front of the sigma sign and doing a times sigma r going from 1 to n of just the function r. That function r was r squared, and you can see that it was the same as leaving it here. Alright, so we'll just highlight that and try and commit that idea to memory. Alright, let's show you another example. Sometimes you'll find you'll get the summation, sigma, of a constant. Let's say the constant is 3. And we've got r going from, say, 1 to 5. What does this mean? Well, when r is 1, you'll notice that we haven't got any function of r attached to the 3. But that doesn't matter. All we've got to do is use this as a kind of counter. When r is 1, the first term is just 3. When r is 2, well, the second term is still 3. And when r is 3, the third term is 3. And when r is 4, we get 3. And when r is 5, we get 3. We in fact have 5 terms of 3. 5 lots of 3. And 5 lots of 3, obviously 15. But the point I want to demonstrate here is that essentially if you have got summation, sigma, of a constant, r going from 1 to n, then you're going to write that value of that constant, a, if you like, you're going to write that down n times over. So what you end up with is n times a. And this too is another rule that I want you to commit to memory. Alright? Okay, well that brings us to the end of this short tutorial on sigma notation.